Okay, now we're on to line 17t3, Electromagnetic Solitons CERN, which is CERN, Boffins, B-O-F-F-I-N-S, Neutrinos Brillouin Proton pulses while SETI. Part 100. This is based on the line 17 WOW SETI alien radio signal. The math equation is 14, 1, 113, 2, and 1. Again, if you're just starting this video series, you want to go to the very beginning of 17A. And actually, if you want to go right from the whole start, you start at video number 1, but you know, take your pick. There's the tags are in the titles actually, and each title tells you what the video is about. So whatever you're interested in, that's what you look at. Okay. Data to read January 25th, 2011. So this is the stuff I did today. This was based on the other, not on line E, but on line 17T2. I had to divide the data. Too much stuff came up. Okay. So electromagnetic solitons and fully relativistic electron-positron plasmas with finite temperature. Nancy Lee, March 3rd, 2011. He wrote a paper about it. And this came up during my search. So, of course, I Googled solitrons because I don't know what they are. And this is what it looks like. Solitrons shape while propagating with n equals 2. It changes its shape periodically. Okay, that's Wiki Soliton Optics. Solitons shape while propagating with n equals 1. It does not change its shape. Okay. And this is based on, this is his data here. It came up. This is what came up with Nancy Lee. Okay. Okay, I'll just read it, what he's got here. The existence of localized structure of electromagnetic waves in relativistic electron-positron plasmas is investigated based on the pseudo-potential theory. So he's written a theory about it, and he sent it out March 2011. It was published June 2011. Without making any assumptions on the magnitudes of the flow velocity and the temperature of the medium. The conditions for the localized electromagnetic wave in the form of dark dip-type soliton are found. In the small amplitude approximation, it is found that the dip becomes deeper and narrow as the temperature is raised. In low temperatures T minus MC squared, localized solution exists only if the equilibrium longitudinal fluid velocity parallel to the direction of propagation in the wave frame is larger than the classical thermal velocity of what that thing is of the plasma. For ultra-relativistically high temperatures, T is that MC squared. It is shown that the dark soliton can exist if the equilibrium longitude velocity is larger than C. And then that thing 3. He works for the American Institute of Physics. And his website's pop.aip.org resource. There it is there. I'll put the link up on my blog, Victoria Stafford, A Psychic Investigation, okay? It's going to take a while for me to put all this information up, just so you know, because I'm on line 17 and I've only blogged line 11. So it'll be a couple weeks. My thoughts continued. So you want to use electromagnetic solitons because they can work at high temperatures. Quote, for ultra-relativistically high temperatures, T MC squared is shown that dark soliton can exist if the equilibrium longitudinal velocity is larger than C V3. Google electromagnetic solitons. And this is what comes up. Okay, electromagnetic solitons. I don't need to read that. That's just my data. Okay. So over here. Oh boy. I got there and I got it over here. I tried to be organized this time and I'm still not organized. Okay, electromagnetic solitons produced by stimulated Brillouin pulsations. Electromagnetic solitons produced in a regime of pulsating stimulated Brillouin scattering are presented. The localized field structures are stable and long-living. Okay, hold on. I don't know what this means. Well, that goes on to the next section. Okay, we'll go over here. Okay, January 25th, 2012 at 12:25 p.m. Eastern Standard Time. My thoughts continued. I did research on this over several days. The term pulsating stimulated Brillouin scattering, these words stand out to me for some reason. I read that they use pulses with the neutrino testing from CERN to Gran Sasso. So I googled the pulses used with neutrino CERN test, and the data on the right comes up. Uh-oh. I've kind of moved my notes around. Sorry. CERN Boffins rerunning neutrinos pretest proton pulse. Quote from data on right. They use 10 microsecond bursts of protons at CERN to generate the... Oh boy. I moved all my notes around and messed them up. Sorry. My thoughts continued. At CERN, you used shorter pulses in test number 2 in January 2012 with better results from the neutrinos. So I am assuming that it's either faster or the exact same rate of speed. Have you tried this method that I found during my Google search on this Luli Polytech PDF file, link above? Google pulsating stimulated Brillouin scattering. That's it there. www.luli.polytechnique.fr, and then there's documents, okay? Okay, so we're going to Google pulsating stimulated Brillouin scattering. There's a new test from September the 27th, 2010 that came up. New version was February 10th, 2011 from Spain comes up. Quote, pulsing the probe wave to reduce non-local effects in Brillouin optical time domain analysis BOTDA sensors. And then this was the link that came up. CERN Boffins rerunning neutrino speed test. CERN Boffins rerunning neutrino speed test to correlate the received neutrinos with the proton pulse that creates them. The old experimental design which used 10 microsecond bursts of protons at CERN to generate. Data to read about Boffins. Boffins play ping pong with a single electron. Sounds more like a pinball to us, but they're Boffins. This was posted by Brillouin Parnell. Get more from this author. Posted in Physics. September 23rd, 2011. Researchers at Cambridge University have managed to bat an electronic back and forth along a wire in a high-tech game of ping pong that could help out with quantum computing. The findings published in Nature showed the Boffins were able to exercise a high level of control over the path of an electron in an electronic circuit. Taking firm control of an electron in a circuit is not easy to do, as usually an electron carrying a current along a wire takes a complicated zigzag path instead of going straight to the other end. When the electron is carrying information, these are annoying detours that can cause it to drop any information. It might be carrying, or in science speak, the quantum state loses coherence. The Cambridge Uni scientists trapped their electron in a quantum dot, a small hole in the surface of a piece of gallium arsenide. Then they created a channel of a higher energy than surrounding electrons, which led to another dot that was empty. A burst of sound carries the electron from one dot to the next on an acoustic wave, and another burst sends it back again. The researchers got rallies of up to 60 shots before going before, as they intriguingly put it, anything goes wrong. There's a lot of work going on worldwide to make this new type of computer, which may solve certain complex problems much faster than classical computers. However, little effort has yet been put into connecting up different components, such as processor and memory. Gee, I think I've been doing that with this video series, just so you know. I'm serious. You're going to have to go through all the videos because all that data, seriously, did come up. Said the top Boffin from the semiconductor physics group, Chris Ford. Although our experiments do not yet show that electrons remember their quantum state, that is likely to be the case. This would make the method of transfer a candidate for moving quantum bits of information, qubits, around a quantum circuit in a quantum computer. Oh. Who would have known, eh? Okay, so I read that. Okay, so January 25th, 2012, 12:25 p.m. Eastern Standard Time, my thoughts continued. I did research on this over several days. The term pulsating stimulated Brillouin scattering, these words stand out for me for some reason. And I read you that one. Okay, Oh yeah, that's where it goes. So they use 10 microsecond bursts of protons at CERN to generate. That's what they use to do the test with the neutrinos, okay? So here's my next set of notes. January 25th, 2012, 12:40 p.m. Eastern Standard Time. This is in relation to all the new data that came up today. In conclusion for line 17T. My thoughts continued from new data found on Boffins and proton pulse Google searching. It looks like they are currently working on a new type of data transfer rate with these Boffins because it refers to them being used in faster computers. Wouldn't that be nice? I bought the fastest computer and I still find it's too slow for me. I like to do tons of things at once. I get bored easily, so I'm always switching gears from one task to another on my computer. I get frustrated with how long it takes to find stuff on it. It would be nice if they could create a search tool on the computer that comes up with one note to look at all notations, not just the stuff we type, but the stuff we copy and paste. We still don't have that function on our computers or on the Google searching. I didn't notice it until I started working on this wow signal data stuff. The good thing is each test that I find, there's more things we learn. Now it looks like other companies are check out this neutrino problem and trying to solve it from different countries. Each facility tends to add new ideas and test results with even more surprising data. Talk about the age of enlightenment. I'm beginning to believe the Mayan prophecies are definitely coming true. It's like back in the early 1900s. Thousands of patents and inventions were discovered. I think 2012 will be the same thing. A new era in technology. If we can tap into this alien technology that is far above our own, our timelines would be shortened. When I read that it's taken us 30 years to develop something or learn about it, and it costs us millions and billions of dollars, I'm thinking, what a waste of brain power. Surely with our brains we can find out more things much faster. They say we only use 10% of our brain matter. Why aren't we trying to figure out how to use the other 90%? It might help us find our answers quickly and save us oodles of dollars in the long run. Okay, so the next section is going to be 17T4. We're going to be taking a break from the WOW SETI signal with 17T4. And what happened is I had another episode or another math equation come to me, and it's from the Maya, and it's in regards to black hole, travel, universe, and stuff. Okay?